Alright, so we didn't finish all of our problems in class on Tuesday, and since you're finishing them today, I wanted to record this so you can check your answers. Or if you're really stuck, you can follow along with me. So most of my classes we finished number 4, but some people didn't, so I'm going to start with number 4 and then go through. If you just want to check one, you can kind of fast forward through it. Okay, so number 4, there are 11 yards of ribbon that we're sharing equally with 4 people. Alright, for my model, I'm going to draw 11. I like to draw just squares. I think they're the easiest things to divide up if I have to. There's 3, 6, 9, 10, 11. Okay? I'm sharing them with 4 people. We're going to call them person 1, 2, 3, and 4. So person 1, you get this one. Person 2, person 3, person 4. Do I have enough to give everyone a whole again? Yes, I do. 1, 2, 3, 4. Okay, cool. Do I have enough to give everyone another whole? No, I don't. I have 3, and I needed 4 wholes if I was going to do that. So now I'm going to have to start breaking them apart. My strategy, I know I'm going to have to share with 4 people, so I'm going to break each of these into 4 parts. I'm going to give this one to person 1, 2, 3, 4, person 1, 2, 3, 4, person 1, 2, 3, 4. Now using my model, I'm going to figure out how much ribbon does each person get. My favorite number is 2, so I'm just going to pretend I'm person 2. Person 2 gets this one. They get this one, they get this little piece, they get this little piece, and they get this little piece. Alright, that is 1, 2 holes, and 1, 2, 3 parts. My numerator is how many parts I have. My denominator tells me out of how many parts that would make a whole. Well, this is 1 whole, and there are 1, 2, 3, 4 equal parts in it. So 3 parts out of the 4 it would take to make a whole. That's how I'd solve my problem with a model. With math, I'm going to ask, well, which would I be more comfortable cutting apart? Yards of ribbon or human people? If you think you're capable of cutting apart human people, that's not so good. I'll cut apart the ribbon. That means 11 is being divided up into 4 parts instead of cutting up people to give them to ribbons. That's okay. So 11 divided by 4, my divisor, nope, that's not right. My dividend is the thing that I'm comfortable cutting up, and that goes inside. My divisor is how many groups I'm cutting it up into, that goes outside. Well, can I make groups of 4 if I have 1? No. 0. 0 times 4 is 0. 1. Bring down the 1. How many groups of 4 are in 11? 2 groups. 2 times 4 is 8. Subtract. That leaves me with 3 left over and nothing to bring down. Now, if this was a decimal, we could add a decimal, add some zeros, and keep going. It's not. It's a fraction problem, so I'm going to say that my answer is a mixed number. It is 2 whole groups of 4 and 3 parts out of the 4 parts it takes to make a whole group. Ta-da! Each person gets 2 whole yards and 3/4 of a yard of ribbon. Next one, number 5. Which expression is best represented by this picture? Here's the strategy. Let's start with pretending that these groups were never drawn. How many whole squares do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's what I had before I started breaking things up. So that is what I have to break up, 16 holes. Now they're broken up into groups of, well, here's 1 hole, 2 holes, 3 holes, 4 holes, and 1, 2 parts out of the 3 parts it takes to make a hole. This is a group of 4 2/3. Let's double check. Here's 1, 2, 3, 4 holes, and 1, 2 of the parts out of 3 that it takes to make a hole. This one right here is a little bit more confusing. I've got 1 hole, 2 holes, 3 holes, 4 holes, 1 part, and then over here there's another 1 part. 1/3 plus 1/3 is 2/3. This is also a group of 4 2/3. This is not a group. Then we have our answer. This not a group part is going to be our remainder, our fractional remainder. But don't I have 3 whole groups of 4 2/3? Yes, I do. The size of the group is 4 2/3. The answer is going to be 3 3/7. This is the expression that best represents this problem. If you're curious how I got the 3/7, well, what's left? I have 1, 2, 3, 4, 5, 6 parts out of how many parts that make a group? Well, here was one of our group. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 parts that are a size of a third in this group. 6/14 simplifies to 3/7. So that's where my remainder came from. I have 3 whole groups of 4 2/3, and this little bit of extra is represented as 6 out of the 14 thirds that it would take to make a group, which simplifies to 3/7. You don't need to know that part because I gave you equals 3/7. But another strategy, if you're really confused, would be to look at each of the answer choices, solve it, and see which one has an answer of 3 3/7. Number 6. There are 1.5 pounds of sunflower seeds being shared by 6 people. When you're drawing models, the bigger, the better. I'm going to cut this one in half and say I don't need that other half. You can put an X there, or if you have a highlighter, highlighters are really helpful because you can still draw over them. So I have 1.5 pounds of sunflower seeds here. I want to share them with 6 people. Okay, well this is in halves. So I might start by trying to cut this in halves. Now I have 1, 2, 3 equal parts. Okay, I need 6 equal parts. So I'm going to cut each of those halves in half again. Now I have 1, 2, 3, 4, 5, 6 equal parts. Excellent. What is the size of each part? It is 1/4. So each person number 1 gets this one, person number 2 gets this one, person number 3, person number 4, person number 5, person number 6. Each person gets 1/4 of a pound of sunflower seeds. If you want to solve it with math, we would say, do you want to cut up people or do you want to break up groups of sunflower seeds? Again, cutting up people is murder, that's bad. So we're going to break apart our sunflower seeds. Because I don't mind if I have a piece of a pound of sunflowers, but if you give me a piece of a person, I'm not eating that. That's gross. What we're comfortable breaking up into how many groups or the size of the group. Now, to do division with fractions, I need them to both be only fractions, not a mixed number, not a whole number. So I'm going to use the Texas method. I'm going to multiply 2 times 1, that's 2. Plus 1 is 3. Keep my original denominator. 6 is the same as 6 one-sized pieces, or whole-sized pieces. And now I can use SURS. The same, the inverse, the reciprocal, don't forget to simplify. The same fraction is still 3/2. The inverse operation of division is now multiplication. The reciprocal is when I flip. Now I have 1/6 instead of 6/1. I'm going to multiply. 3 times 1 is 3. 2 times 6 is 12. And now I'm going to simplify. The greatest common factor between 3 and 12. 1, 12, 2, 6, 3, 4. The greatest common factor is 3. So I'm going to divide by 3/3. 3 divided by 3 is 1. 12 divided by 3 is 4. Oh hey, that looks pretty familiar. 1/4. That's how many pounds of sunflower seeds each person gets. We got 2 more. Again, I'm not trying to teach you these right now. You should have tried them on your own. I'm just reviewing the answers for you. What equation does this represent? Well, let's start. We have 1, 2, 3, 4 holes and what looks like 2/8. 4 and 2/8. What could it maybe be broken up into? I don't know. Sometimes you kind of have to look at your options.